Look at that, now we're recording.
That's how you do it.
Hey, and welcome to the Hackaday podcast. My name's Elliot Williams. I'm editor-in-chief of Hackaday.
And I'm Kristina Panos, assignments editor.
This is episode 156. Today we'll be talking about 3D printing rainbows, split flap clocks, swapping EV car batteries, and floppy time. Hello and welcome to the show, Kristina.
Thank you. It's great to be here.
You've been a guest on the show before once a while back. What was that?
I want to say 112?
So 40 episodes ago. My God, that's almost a year.
Are you kidding me? Wow. Oh yeah, it was like May.
Seems like just yesterday.
It does. Or last week.
Or 28 seconds ago. Well, for those of you who don't know, Kristina is our resident keyboard expert. She started off writing a column, Inputs of Interest, which was about wacky peripheral inputs, and then finally gave up and admitted that it was really keyboards were her main love, and has been holding down the Keybing with Kristina column for, past half a year or so, or longer.
Yeah, the last one was number 10.
And you always manage to come up with new and interesting things. Like, there are keyboards and typewriters, the range of strange typewriters that you have been able to come up with so far is pretty amazing.
Oh, thank you. Yeah, I have a couple of hives of good information for that. A couple of troves.
It's good to cultivate your hives.
Oh, yeah.
So how did you get into high-end / ergonomic / crazy keyboards?
I came by it honestly with my repetitive stress injury, but before I had used Microsoft Natural keyboards on and off, and then recently I had like a Logitech Wave that's kind of a split, but it's really laid out pretty well for a rectangle. Then I went to this one because I had to try something else, and it seemed like a good idea, and it turned out to be a really good idea because I didn't think I'd be able to computer ever again for more than an hour at a time.
Yikes. And this one is
I have a Kinesis Advantage. It's 20 years old.
Oh, wow. Yeah, for those of you who don't know, this is the one with the finger bowls in which you type. Like, the keyboard itself is round and curved away so that you don't have to stretch your fingers up particularly, right?
Right, hardly at all. And it's ortholinear, but it's column staggered.
Okay.
So like Q, A, Z are all lined up, but the columns are a little off from each other just because the lengths of your fingers are different. So they took that into consideration too.
It seems like a really crazy design if you're not a keyboard nerd, but then once you are a keyboard nerd, it actually seems like all they did was put the keys under where your fingers go.
Yeah.
Which hardly seems revolutionary or crazy at all, actually.
Well, plus the thumb clusters really do a lot because you got 6 buttons under each thumb now, whereas before you just had spacebar.
My keyboard has a lot of action going on the thumbs, and I don't know if it's smart. I can definitely type like this, but I definitely think that just a space bar on your thumbs is kind of a waste, but I maybe have gone the opposite way and just totally overloaded my poor thumbs.
Yeah, I mean, it sounds like it. I haven't tried it. I'm not a fan of the concept of layers because I would just rather have most of the keys that I need. And just if you're getting to where you have to hold down however many keys and do it all the time, then you're kind of getting back toward a repetitive stress injury situation.
Yeah,
potentially.
You might well be right. Anyway, I need to make another keyboard. This was actually the first keyboard I ever made myself. I mean, it's the second version of it, but it's the first keyboard I ever made myself. And if you're hand wiring it, it kind of seems like a good idea to minimize the number of switches because it's just a lot more work.
Yeah.
And so that's kind of the lame path that I took when I made this thing. I also was kind of rationalizing it as being my travel keyboard. But I also did ortho and I guess staggered, you were saying, like the ones that go under your middle finger are a little bit higher up, and that's really nice. And once you get used to that feel, you can actually tell that it's easier on your fingers than having to like creep up and over for this kind of like weird offset rows that normal keyboards do, which
Oh, yeah.
I guess is a byproduct of them being for typewriters or something, right?
That is controversial.
Ooh.
Whether QWERTY actually comes from type bars sticking together or not is up for debate.
Really?
Yeah, that's what I hear.
Well, what's not up for debate is that we definitely enjoy reading your column and figuring out, A, the news in kind of the current do-it-yourself keyboard scene, but then also these crazy random old ones that you pull up. It's good fun.
Oh, good. I'm glad you enjoy it.
This is a journey into sound.
What's that sound?
What's that sound?
For this week's What's That Sound, I wanted to give Kristina a keyboard sound and test her otherwise superb keyboard knowledge. So I guess it's giving it away a little bit. This is the sound of a keyboard. Can Kristina tell, and can you, our listener at home, tell what these key switches are?
Pitter patter.
What's your guess?
They sound like angry
Ah,
me.
correct. I'm going to have to
Hooray.
bleep that out, of course, so that our listeners at home don't also get angry. But if you know what kind of keys these are, send your answer on in. Head over to the podcast website at Hackaday/podcast. They'll find a form where you can enter your name and your guess. And we will select randomly from the correct answers. If you are the winner, we'll get you a Hackaday podcast t-shirt.
Do I get a Hackaday podcast t-shirt?
It seems really sad that our guests don't get Hackaday podcast t-shirts.
That is sad.
Twist my arm. All right, podcast t-shirts. No, I've wanted a Hackaday podcast t-shirt too. I might have to do it. I need to get Mike one too. All right, my first hack this week comes from Alfredo Cortellini. It is a Solari mechanical digital clock hack with a little extra. And this is a fantastic old, I guess, 60s, 70s split flap clock. And these were these kind of remote clocks that would be in like a large company, all fired off by the same central clock server. And just like an electrical pulse goes to them and they flip to the next minute. Without the clock brains to drive it, these things are useless. And so part of Alfredo's project here is to hook a microcontroller with a modern clock into the thing to drive the solenoid to make it flip to the next minute. But the really clever part of this is how he sets it up so that it can set the time itself. Normally, these clocks, you'd have to go around the back and wiggle some gears and stuff with your hands to set them to the right time. And from then on, they would, of course, keep up with the central clock. But he doesn't have the central clock, and he doesn't want to go around the back and reset it. So what he does is work out a fantastic mechanism with a magnet and some Hall effect sensors. He can tell when the minutes switches over from 59 back to 0. He's also added a servo motor in there to push this bar linkage that makes the hours advance. And as a final touch, there's a sensor in there that tells when the end of the day has been reached. And so combining these three together, he can zero out the minutes and then advance the hours until it sees that it's come to a new day. And then he knows he's zeroed out the hours. And then from there, he can advance the minutes and hours separately to set the time. If you can imagine trying to set this clock with only control over the minutes, you would drive yourself insane if you had to click it 60 times every hour. And it's a 24-hour clock, of course. So if you want to get from like 10 o'clock to back to 9 o'clock, you'd have to do it like 23 times, 60 times. It would be split flapping for like half the day before it even got there. Did you see the video on this one?
I did. It's very cool. It's a beautiful clock.
Yeah, right? I really love watching it set once you know how this mechanism inside works. Like the way it does minutes and then hours is actually really pretty clever. I wonder if he's doing it because he doesn't want it to run all the time, if he wants to let it kind of not click all night when he's sleeping or something.
Yeah, maybe.
Because that would be a pretty strong incentive to have the thing able to set itself.
Unless you keep it out in the shop.
I want one of these. I actually went onto eBay looking because I figured, it's a busted old clock. It doesn't even have the clock brains in it. How much can one of these cost? And they are probably collector's items because the one I saw that was an auction that was about to expire was selling for almost 450 euros. Yikes. And so this isn't the cheap hack that I thought it was going to be. So I'm a little bit dashed, but that just makes Alfredo's hack even nicer because while he does have to glue some magnets onto the clock and, of course, 3D print some parts to do the shoving around of the mechanicals, I don't think he's actually modified the clock all that much. And so, given that it's probably a multiple $100 clock, he probably hasn't done it any harm.
Well, we love that. For my first hack, I chose Sticker Brings the Heat. Carl Bujega has been making flex PCBs for a while, and most recently he's been making heat with traces on a flex PCB that seems to come with adhesive backing. Now, the traces themselves don't flex very well. He started out with some long snaking back and forth, so he had to get creative with a constantly changing squiggle so that it would flex better. The only problems, he did a bunch of testing and found that high heat will discolor the substrate, which is whatever to me. It just gets darker, which seems to be fine. I mean, depends on the application, but it also melts the adhesive, which is bad.
Ooh.
He wrecked a few drinking glasses with some stuck adhesive, but he concluded that they are good for low temperatures for long times, as in a wearable, or high temperatures for short times, which was good for SMD soldering, actually.
That's insane.
Yeah, he shows a bit of that in the video, and it's... I would love to have some for pain relief patches, or hand warmers. I've been trying to scheme a heated mouse of some kind for a while, and I think if I could... It would fit on the mouse pretty well if you could get it to flex around the curve. I use a trackball, so it's kind of got some weird geometry to it.
You're the fabric master here too. You could probably cut some what are they even called? You even know the terminology for this. Some triangle-y cutouts or something so that you can fold it together just right. Darts? No, the opposite of darts. They're
pleats? Tucks?
Tucks, probably. What do I know?
I might have to do that. Well, speaking of Kapton, there's an older heating pad method out there that's just like a grid of nichrome wire slapped in between two pieces of Kapton. I've played with those a little bit. Those are very flexible. I'm not sure how resistant nichrome wire is to breaking over long periods of flexing, but...
I guess they do make, electrically heated gloves and stuff like that. And those are probably using nichrome or something else, right?
Yeah, I would think so.
So there must be a way to do it, and that probably is the traditional way to do it.
Yeah, it's probably easier to make a PCB, though, than...
Oh, for sure.
a grid of nichrome wire. He did tease a video with much smaller ones on a pair of gloves.
Ooh.
So I suppose if you just make smaller ones and use more, I don't know.
Yeah, and then flexible wiring between them.
Yeah.
Cool. We'll keep our eyes out. My next hack, filament dry box design, goes way over the top, is maybe a little questionable. I'm not sure I need a filament dry box, but what isn't questionable is that this hack goes way over the top. Sasha here has put basically the whole armada of IoT sensors, controls. It's got an API, it's got a web server, it's got control of a fan, it's got 2 humidity and temperature sensors, one for inside the box, one for outside the box. I guess the original box he used for this has a heater inside it, but he's added control to that as well. And so with an ESP32 that has an embedded web server and serves up all this data, both human readable over a web page, but also with a custom API to hook into basically it's N8N, which is an open source kind of if this then that like service. Anyway, my point is this is an entire home automation IoT system crammed into a little filament drying box. For all this work, he gets a couple really neat features, including he knows how hot it is in the box, and by having control of the fan, he can keep that temperature distribution kind of even inside the box. He can keep the heater from getting too hot, which was his worry with the original design. You just plug it into 12 volts. If it gets so hot that it starts melting your filament, or if there's a hot spot locally around the heater and it melts your filament, well, you're having a bad day. So this really does seem like the kind of device that would need a little bit of feedback control. So maybe in that sense, it's not totally over the top.
Well, you mentioned a lot of sensors, but I didn't hear anything about filament remaining.
Oh, man. Yeah, he doesn't have a filament remaining sensor in there. Bah, Kristina, that is brilliant. We will have to write him and let him know that what he needs to do is, put like at least a number of rotations counter on the spool or something. He should be able to do that pretty easily.
Maybe do it optically.
Yeah, right? Have a little white-black piece of paper or something.
Couldn't you just do it by weight?
Oh, that's good too. Yeah, sure. You could just have a weight sensor in there, and then you'd know that you've used up 200 grams of your 1 kilogram of filament.
Yeah.
Ooh, that's really good. That's the easy way to do it, actually. Yep. Anyway, depending on who you ask, you can avoid this whole project because I would like to point out, let's see, in November of last year, Thomas Senlander looked into whether you really need to dry filament at all, and in his YouTube video, I'll throw the links in the show notes, he comes to the conclusion that you maybe don't. He soaks filament actually in water for multiple hours, and it doesn't absorb significant amounts of water at all. He weighs them before and after, and then he prints it, and the wetter filament does probably string a little bit more, but when he subjects it to his trademark strength tests, it's no weaker for being wet. And so, I don't know. I personally have never been in the drying filament camp, but, I also just leave it in its bag with the little silica gel in there just because, why wouldn't you, right? So maybe I'm treating my filament fairly well, but I'm certainly not going to the extremes that Sasha does here. The extremes are kind of a goal in and of themselves, and I view this project both as a super overkill dry box design, but then also as a dry run for a home automation system. And so even if you're not into 3D printing and aren't worried about keeping your filament dry, you might want to give this project a look, because if you installed the same thing in your house, it could control your entire house's heating and cooling needs.
Oh, I'm not a dry boxer either.
Are you a 3D printerer?
Sort of. I'm a spectator. I mean, we have 4 of them, but they're his.
Yeah.
So I know how it's done. He actually just got a new Lulzbot Mini, even though they're flirting with insolvency.
Yeah.
And the multi-material extruder is on its way.
Oh, fancy.
Yeah. So we can finally do that Riskables void switch keyboard that I'm supposed to be doing. My next hack is 3D printing rainbows, because when your daughter wants sparkly unicorns, you better deliver. The Action Lab is our hacker here, and he had used a diffraction grating in the past to make pretty chocolate, and then tried it with PLA, and it worked just fine. I was not aware that I was, in fact, already aware of diffraction gratings as a thing. I have a trinket from Maker Faire that is a little diffraction medallion. You look through it and you can see the rainbows. I never thought to shine a light through it. I was going to show you, but you're not on the video. I was going to put it up to my camera so you could see through it.
Yeah. Oh, I love diffraction gratings. My son actually has a pair of diffraction grating glasses that we got somewhere.
Ooh.
And he loves to run around them and, look at the various lights in the house and crazy stuff like that. It's pretty trippy.
Nice. Doesn't sound very good for your eyes, though.
I have no idea.
Better than wearing somebody else's glasses for a long time, probably.
Yeah. It does look a little bit fuzzy, doesn't it? I mean, in addition to the crazy rainbow patterns you get everywhere.
Yeah, a little Vaseline on the lens there, kind of action.
Yeah, exactly. Yeah. So how big is your diffraction grating? What size of 3D print are you going to be able to pull off on it?
Oh, it's very, very, very small.
Wonder where you get these really big ones. I mean, it must be something you can just, these days you could probably just order it on eBay. What do I know?
There's that American Science and Surplus catalog or something.
Cool.
Probably has them.
Yeah, totally.
Yeah, I think that's what it's called. They got a bunch of crazy stuff.
I'm actually a little bit surprised that it's able to, smoosh the plastic surface down into the diffraction grating enough that it actually transfers over. I mean, these things work by having like tiny little, essentially micro scratches in them to make it transfer over into the print. He must have to really lay the first layer on thick or hard or something like that to squish it into all the little crevices.
Yeah, I don't know. I feel like I'm less surprised about the chocolate, but you have more control over the chocolate. I don't know.
Oh, I'm looking at the video now for my first time. That's actually really awesome looking. All right, that's it. I'm gonna have to find some diffraction grating and put it on my 3D printer bed. That is actually really cool looking. I wonder how durable that the sheet is, or if you like ruin it after 2 prints.
Ooh.
Or if I'm able to just keep it on there and print everything with a sparkly bottom. It sounded weird.
I wonder if you could make a resin one, make it your new bed.
I guess as long as you could pull the diffraction grating off of it. If it doesn't stick to it, I wouldn't see why you couldn't. Well, speaking of crazy printing hacks, this next one, Print a Sketch, turns any surface into a printed circuit board, is really neat. It's a research project from Narius Pourjafarian and her team at Saarland University. The basic idea is to take a modified inkjet printer head and run conductive ink through it, which sounds pretty cool already, but the next trick is to embed both a mouse sensor camera and a regular Raspberry Pi camera into the same device so that it knows where it's going as it moves across the surface, and it can see it with using computer vision algorithms at the same time. This lets them pull off a couple really neat tricks. First of all, the dosing of the ink coming out of the inkjet head is super critical to make a conductive ink trace. And if you're just dragging it with your hand, you don't really know how fast the ink head is moving across the surface. So getting the amount of ink just right is really hard. That's why they threw a mouse sensor in there. So with the mouse sensor, you know how far it has traveled and can adjust the inkjet pulses appropriately. The other really cool thing it does is it notices if you've wiggled a little bit left or right. And so it can actually draw straight lines for you even if your hand isn't moving in a perfectly straight line, because the inkjet printer head prints about 8 millimeters wide or something, and if it's only printing a 2 millimeter wide trace, it's got a lot of wiggle room, and using its inbuilt smarts, it can move the line to the left or right to compensate you moving right or left. So it's a little bit like, what is the name of that crazy smart router, handheld router that's got, I've demoed one and I can't remember the name. Anyway, it's a super cool use of smarts on board. They also use the camera to do some really clever things like take pictures of a part that you would like to print a footprint for, and then the inkjet can automatically like put out a dip 8 pattern for you if you've shown it a dip 8 package. It can also copy other arbitrary patterns you want. So if you draw like a heart, you can make it print hearts in conductive ink as you go across. It also is smart enough to avoid connecting traces where they're not supposed to. So it will actually like drive around a little bit of other circuitry to keep you from drawing 2 lines over each other if they're not supposed to be connected. The brains of this is a Raspberry Pi. It's a standard OV52 something Raspberry Pi camera in there. The mouse sensor is pretty normal. Like nothing here is super out there in terms of being technologically advanced, but by putting it all together with some really clever software, it does some things like drawing straight lines where your hand is wiggling that actually look like magic.
My next hack is from Jan Derogi. It's always floppy time. This is one of the coolest clocks I've ever seen. It consists of a box of floppies that tells time. One row tells you the hour and the other tells you the minutes. Now it's sitting on a stack of magazines, and those magazines are hollowed out, and inside are cams that raise the correct floppies for the hour and the minute, and the floppies have numbers written on them in Sharpie. The really cool part is that no viable floppies were harmed, because they did have to be cut a little bit to attach to the cams, but they're all from a game. And on the hour, instead of chimes, you get whatever disc, you get that game's theme song played through a Nokia phone, which just takes the cake right there for me. And I like that Jan snuck in the A-Team theme in lieu of a 24th game. It's a 24-hour clock.
Right.
So there's 23 game theme songs and the A-Team.
I watched the video, and his videos are always really amusing. He's got kind of a fun sense of humor. But this one, watching the floppies like rise up and down in their like slow wave is really fantastic. It definitely makes you want one of these. Again, this is not a small undertaking. He's nice about filming his experiments and his failures and all the rest. And this looks like an epic project in a way. Like you said, the floppies had to be trimmed down to fit exactly. And he went through however many different revisions of the spoolie cam things that push them up and down. And, there's a lot of craftsmanship here and everywhere. This was definitely a labor of love. But when the clock rings like Lemmings 30, that's just pretty cool. My first quick hack this week is Ken Vandervelden's AR display shows CNC lathe operations in real time. He adds rotation sensors to his lathe and then fires off a camera exactly when the lathe head turns to the same angle. So he can get kind of a stop motion effect going on. And then he also takes data from the lathe itself, so it knows how deep the cut is and how far it's been and where its positions are. It has the whole digital readout thing, and it pumps them into a heads-up display glasses that the operator can wear. What this means is through one eye, you can look at machining as it normally is, and through the other, you can see it as if the workpiece were stopped, and it shows the cutting path and stuff going along. It's not open source as far as I can tell, but it's a really neat idea. You should check the video out. Next up, JP3141, accurately track your mains frequency. This is a really neat project to look at the super tiny deviations in the frequency of AC mains wiring. If you collect a bunch of this data, it'll show you kind of the health of the overall power grid, because as more load comes on, the generators actually slow down a little bit, and you can see this in the power line. To do this, it means you have to build a super accurate clock into your microcontroller, which is a really neat part of this. And then he also verifies it against a university-sponsored research project, FNNet/GridEye, which you should check out if you're into grid frequency monitoring. It looks like he's basically made their device for them, but a cheaper, accurate version of it. And so it's a pretty cool hack. And last up, Dead Mouse reincarnated as MacroPad. Taylor found a broken mouse in a thrift store, but is a 12-button mouse. And what do you do with 12 buttons on a mouse? I have no idea, But Taylor makes a 12-button macro pad. This ends up being a really simple hack because all he has to do is rewire the button switches off of the mouse's PCB into a bunch of keyboard switches. And then because the computer recognizes it, he can use all of the Logitech software to customize this mouse's button actions. And so it kind of makes use of this like thrift store find and then a bunch of software that was meant to go along with it and gives it new life. I thought that was really cute.
My first quick hack this week comes from a French artistic duo called, and I'm going to butcher this, Pinafo Pluvinage. Pyrotechnic posters are fireworks drawn on paper. Now this is just pretty. It's a bunch of pyrotechnic powders of different kinds that make for cool designs because they do different things. Some of them flash, and some of them burn slowly, and some of them burn quickly. And it's shiny, and they remind me of wood burning with the homemade lightning. Second up is Lone Soul Surfers spins some spudgers from secondhand silverware. Lone Soul Surfers making a quick departure from electronics to make a tool. And maybe spudgers should be plastic for some things, but not everything is so delicate that a nice heirloom quality spudger will do damage to it. So I think this is a great idea. You can get flatware all day long at the thrift store for however much, 29 cents a piece, and you can usually find some nice fancy handled stuff that would look pretty cool. And lastly, how to lose. This mini bike will land you in hot water. First of all, I just love Lou's style for one thing. He wastes no time. I totally appreciate the dedication to caffeine and creativity and simplicity here. It reminds me of the other ways we've seen to make hot water. We've seen several rocket stoves and hobo stoves, but this is the simplest one. He's using the exhaust from a mini bike to heat up water for coffee or ramen. Basically, he uses a glass bottle and copper tubing, shoved a rod into the exhaust and wrapped the tubing around it and shoved it into a cork, put the cork in the bottle and turns the bottle upside down. Water gets hot, water falls down into the mug.
All right, that brings us to our can't miss hacks. These are long-form original content pieces written by our fantastic Hackaday writers. And this week I'd like to start out with Lewin Day's China Loves Battery Swapping EVs, but will they ever make it here? I didn't know that actually battery swapping cars was a thing. It's actually a great idea if you think about it, because the batteries back in the old days of electric vehicles, people used to worry about the batteries aging. And this kind of takes that worry away from you. If you're just renting the battery for this charge and then you swap it out at a battery charging station for a new one, you don't have to worry about any of that. It's also faster than charging up a battery from scratch, right? You drive into this robot machine, it pulls the old battery out and shoves a new already charged battery up there. Only takes about like 5 minutes or something. What I thought was cool about this is that this is happening now in some cities in China. And I guess one of the factors you'd want to consider here is that you have a high enough population density to make it worthwhile to run these things, right? Because people have to drive into your robot battery swapper. But there were also a couple examples of kind of low-tech versions of this where like kind of mom and pop battery swappers were trading out batteries for taxi cabs, for electric taxi cabs. I think that's really cool. What is keeping this from working in the US, I think, is that all of our cars have the batteries built into them, and a lot of the different car companies kind of insist on range above everything else. And because these batteries have to be kind of smaller and interchangeable from one car model to another, they can't maximize space in the cars like the Tesla batteries or any of the other Western car companies do with their batteries. They just like fill up the car with battery. These have to be easier to swap out, so they're a little bit smaller and they don't have the same range. But on the other hand, if you can get a new battery swapped in for like 5 minutes and however much it costs for the fill, That's a really interesting idea.
I like it better than the massless battery,
The massless battery? How's that work?
where the frame is the IRC. The frame is the battery.
Oh, right.
Because that's just scary if you get in a wreck.
Yeah. I think it's really interesting. I mean, there's also kind of a coordination problem that they're able to solve in China. I mean, I think the Chinese government kind of came in and said to all of its EV manufacturers, if you're going to do swap outable batteries, they have to be interoperable with each other. And so they are kind of getting regulated onto them, this compatibility across 3 different firms that are making cars that take these batteries. And so that kind of, in some sense, helps, right? I guess we have the same situation with the chargers for electric cars in the West. There are kind of 1 or 2 standards for the chargers. So you can plug the same plug into your Tesla as you would into your Mercedes EV or your Volvo EV. Whereas they're going like 1 step further, and they're saying the batteries themselves have to be removable, and then you can plug in other batteries into them.
Yeah, it's a great idea. I don't know if it would ever happen here, though. The regulation part that would make it happen.
And again, I guess if you drive really far, maybe you do want, the extra range that an inbuilt battery can get you. I don't know. I watched some of these videos, and the charging stations themselves are really neat. They're unmanned. It's all automated. It kind of lifts your car up, and then a robotic platform comes up from the bottom, grabs the battery, disengages it, and then it goes in an underground roller to get it charged, and then another one rolls in and gets inserted into the car. I mean, we like having a stack of rechargeable batteries ready to throw into whatever kind of random consumer junk around the house. Like, it's kind of the same thing. Car version.
My can't miss article is Dan Maloney's first days with a new microscope. Dan got a new microscope, finally. And I say that because he really did his research, as you do, for big ticket items. And I totally understand wanting to do that, especially something so fragile and, dare I say, intimate, since you have to put your eyeballs all over it. I personally have not touched a microscope for a while, since school. But Dan decided that he was at the stage where he needed a microscope so he could do SMD repair, citing his failure to repair an Xbox. And I believe Dan has experience with scopes from a biology standpoint, so he knows what he likes, and he chose a stereo microscope, and I know I would prefer that because I don't like closing one eye for very long at all. I was really surprised. I love his umbilical solution to the mess of wires that it created, and I was surprised that mess of wires is plan A for a microscope and that it didn't come with a wire wrap of some kind.
Yeah, right?
Yeah, I thought it looked great.
I do have to say that stereo microscope is the best thing ever. I picked up a used one from, I guess, the mid 80s, but, the optics don't get any worse. They were taken good care of, so they don't get any worse over time. That's really fantastic, and stereo is really fun, and especially if you're going to be doing soldering or working underneath it at all. It's entirely useful to have the height. Like, you actually need it if you're going to be soldering or working things around with tweezers under there.
Oh, you mean other than just looking through it and staring and studying?
Yeah, yeah.
Wiggly things.
Which is, to be honest, which is what we did with it. The first time we got it, I think my wife must have spent like 6 hours with her head in the thing the first weekend that we got the scope, because we were just running around and grabbing everything and putting it under the microscope and looking at it, which is what you do, right?
The last thing I looked at with a microscope was I had this ingrown hair on my head, and I pulled it out, and I was like, I have to look at the bulb of it.
Oh, right.
I have to see what this looks like.
I've looked at splinters in my own finger with it.
Nice.
It's actually tremendously helpful if you have a glass splinter, which I did in my finger, right? Hard to see on a good day. You put it under the inspection scope. Oh, damn, there you go. Problem solved. The one thing I'm super jealous about with Dan's is that it's got a third tube. It's got a camera attachment. So it's got the 2 eyepieces for your eyes, but then it's also got I guess it's a trinocular scope, because it's got a tube for adding a camera to. So he can
The camera eye.
he can look at it in stereo and then take pictures at the same time. And it also has an HDMI out and all sorts of fancy stuff that mine doesn't have. And I guess I'm a little bit jealous. But the trade-off is mine doesn't have any wires at all. And I can just like pick it up, plunk it down, use it, put it back on the shelf when I'm done. And that has a certain, just the dead simplicity of that setup has a certain charm too, I guess.
Oh, sure.
But when it comes time to take pictures for Hackaday article, Dan just goes HDMI capture, and I go, ugh, let me find the camera and that horrible little tube that I made that makes it fit to the eyepiece. And
Have you ever played with an otoscope camera?
no, I haven't.
They're pretty cheap. I don't know if you remember one of my pen's articles. I took a very close shot of a G2 to show that they get blobby on the tip.
Uh-huh.
And it was just my $20 little otoscope camera from Amazon.
Ooh. I think Jenny wrote a piece about otoscope cameras and using it for inspection
That's right.
stuff. I'll have to find the link to that and throw it in the show notes too. That's like a super macro camera or something, right?
It's for like your ears, looking in your ears.
If you want to take pictures of things that aren't, for instance, your ears, like the tip of a ballpoint pen, that's actually
Yes.
pretty cool. Significantly less disgusting, although it depends on how globby it is, I guess. Or how clean your ears are.
So clean.
So clean?
So clean.
That about does it for this week's Hackaday podcast. If you enjoyed it, let us know. Write us an email, editor@hackaday.com. Check out the show notes, hackaday.com/podcast. If you've got anything we should know about or have done anything we should know about, write us at tips@hackaday.com. And until next week,
Keep on hacking. Nice.
that's the way the pros do it right there.
Oh dear.
Oh, see, that was professional.
Hooray.
Hooray. Indeed. Oh, son of a thing. Take 7. Oh, we changed the title.
I don't know what else to say.
I think you've said it. Yeah.